Hello, it's Bill again. This time I want to talk about the Big Bang. And I'm starting to see that the Big Bang may not be the moment of creation. It may not be the time when matter was created. It's looking like the Big Bang was probably the moment where space was created. So let's take a step back and talk about host particles and guest particles. So a host particle is every particle is a host particle, and they have their own cosmic horizon. Right now, that cosmic horizon is 13.8 billion light years away, but cosmic horizons can change. They slowly shrink over time. Now, within a host's observable universe, every other particle is a guest particle. Now, these guest particles have been encoded into the host's observable universe, but each guest particle is a host of their own universe in their own right. Okay, so here's what happens. During the Big Bang, remember we had very small cosmic horizon. We have our host particle at the center, and the cosmic horizon is like an inverted black hole, 10 to the negative 18 meters across. And inside that tiny little space are 10 to the 122 Hawking photons. So 10 to the 122 power of Hawking photons. So when the universe gets small enough, when the cosmic horizon actually gets small enough, it compresses these Hawking photons back into matter particles. But these matter particles are not new particles because as soon as they get produced, they immediately get dragged across that cosmic event horizon. They're immediately dragged across the host particle's cosmic event horizon. Now, these little guest particles that crossed, that emerged from Hawking photons, they did not have their own cosmic horizon. These are just copies of data. So when those particles cross the horizon, the newly created particles during the Big Bang, what happens is they're basically turned into space. Every time one of those particles crosses a host's cosmic horizon, it adds one Planck area, and it adds 1 divided by 2 pi Planck lengths in radius. So this is how the universe actually functions. It has a host particle, and you know it's a host because it can't cross its own horizon, but guest particles can. So the way that particles communicate into our universe is a host particle, A, wants to talk to particle B, host particle B. Well, first, host particle A has to talk to guest particle B on A's horizon. And then guest particle B can communicate with host B. But there is this distributed computation that arises from this. So in the Big Bang, when all these Hawking photons were compressed into matter particles, they were immediately dragged across the small, tiny horizons, which immediately added 10 to the 122 Planck areas of the cosmic horizon. That's what gave us our space. Now, when these horizons expanded, they expanded over areas that were out of causal contact. They expand. It's like the horizons sweep across host particles that we didn't know existed because they were on the other side of our cosmic horizon. But now that our cosmic horizon is growing like crazy, it sweeps past the host particles that were out of causal contact. And just how we showed E observable minus E initial equals the sign of energy, well, in this case, E initial is 0, okay? And then the particle appears to blue shift into reality. So this is definitely a distributed network type of thing where every data element is like the master of its own domain, and it copies every other data element into its data set. So you can think of the Big Bang as not the moment of creation, it's the moment of expansion of space. But all of the information in the terms of matter particles already exist. And remember, host particle has to have its host horizon, even at the smallest, 10 to the negative 18 meters. That's a lot of horizon bits. That's 10 to the 18 horizon bits. So that's a lot more information than just one particle. So every host particle is associated with their cosmic horizon. Guest particles don't really have a cosmic horizon. Their hosts do, but a guest particle does not. So the Big Bang basically encodes other host particles as guest particles into a given particle's cosmic horizon. So this is pretty amazing that the universe isn't so much a place, it's a process. It's a distributed computational quantum computer process. And it just so happens that we can live in this space, but fundamentally, it's all about managing information. Anyway, check out my other videos. Make sure to read the descriptions. There's some math in there, some good stuff. Leave some comments. You have you have any questions? I have a new Let's Discover Gravity with Max and me coming out in a few months here. It's going to have some animation, hopefully be a little bit better, a little bit easier to follow. But thanks for following, and we're starting to see how the universe behaves just resolve more and more detail as we embark on this journey of exploration. So thank you very much, and I want you guys to have a great day. Bye-bye.